Okay. Construct a graph of basic life will have x equals 2 to the x. Okay. So, most people. Start out by making a table, we can say start out to construct a graph. A lot of people didn't get the numbers right. So we've been over this. You don't know how to get those numbers and show how you get them and understand the rules and show the rules. You need to be able to do that, because if you can't do that, you don't understand the rules. You don't understand the functions. Okay. And when we start using the functions, you're going to be missing important things. Okay, well, anyhow, do the graph. Now we have to do some transformations that move this graph around by some numbers. I'm not going to make too big of a graph. I'm going to put -2 here and 2 here so I can stand it right or left, depending what comes along. I'm going to put 4 about here. The 2 goes here, 1 goes here, 1/2 goes here, and 1/4 goes down here. That's going to give me points. Again, we graphed this in detail. Let me go over this once. And of course, you should know what the graph looks like. You have to be familiar with these functions because they're the foundation for the whole course. Okay. Now, and I'm seeing. I mean, I saw a lot of correct graphs, but I saw incorrect arithmetic up there that gave us incorrect graphs. Okay. So if you got a graph that didn't look like this, it's because you didn't do the arithmetic right. And very likely because you don't know what the graph of the basic exponential function should look like. Okay. So you got to fix that. Okay, so anyhow, there we have it. Now I say graph by transformations. Okay, well, by transformations, and if you're going to show me the transformations, well, let's assume I've got F. Oh my God. Thinking about us over here breaking the other pieces. So let's just send these back where they belong. Okay. So let's just say that my B value is 4, and my C value is 5, and my A value is 3. Now we talked about why the transformations work the way they do, and it's best you understand why, so that you make sure you get them right. However, you also have the rules, and of course, our assignment was actually looking at the assignment. You can look back and see, because the way I do this is going to depend. Yeah, it was due today. Okay. That was due today, so you should know the rules. You got F of x minus 4, means you shift it 4 units in the horizontal direction. They shift every point 4 units. Well, 4 units is going to be about this far. You're gonna get points like this. Okay. So in green, we got our alpha of x function. In blue, we got f, so that's -4. Now, I haven't yet had a chance to look in detail at the work you submitted for the written assignment. Many of you did, and if you didn't, need to do that. But that written assignment just tells you how to shift. It gives you a bunch of points that don't match any of our basic functions. Okay. And then asks you to move them this way, that way, twice as far on the other side, whatever. Okay, so there we have it. Now, if we want to do f of x plus 5, then we're going to have to raise all these points up 5 units. I'll do that in different colors. So let's make sure we understand. This is 4 units. All these blue arrows are 4 units. And this is 5 units. So this isn't going to be all that well scaled. I'm going to give you a picture. Okay, so we get points that do something like this. Okay, this would be your f of x plus 5. And I didn't write that out. This is written out correctly here. It shows my parentheses. Here's our f of x plus 5. F of x plus 5. That -3 f of x means we take every one of these points, do it on the other side of the x-axis 3 times as far. And use yellow chalk with green because they look kind of similar. For example, this point will go down here. This point, then closer to the x-axis, and you move it 3 times as far, it doesn't go as far. And this point, well, you can't really see what I'm doing, but it ends up about here. This point might end up about here. And this point is going to end up down here, and even further down. So here's your -3 f of x. Now, when I said the basic function consists only of the 5 points. Okay. But then we can do the extended basic function by sketching the curve, which most people want to do, and that's fine. But the reason I want to talk about the basic function is we just look at those 5 points. Where do they go? Now we sketch the curve. Okay. Now, we get 3 curves. All these curves have the same shape. This curve is correct because every point moving 3 times as far. Oh, there it is in my hand. Okay. Okay, the shape of this curve is distorted. It's steeper because we've tripled all the distances from all the y values. And in this case, moved them on the other side. When you triple the y values, the graph gets stretched. Okay, well, we need to understand third useful way of looking at graphs and necessary to understand the scheme of this course, which is why I've been stressing it since the first day. You have to be able to do the arithmetic correctly. You have to know the rules of arithmetic because everything's based on that. Okay. You have to show me that you know it. If you don't know it, go back and review the assignments because the assignments have shown you how to do it. Assignments on exponents, assignments on basic arithmetic. Okay. So what I see here, as far as knowing that this is how you construct a graph, that's good. Some of the arithmetic was off. Fix that. Okay. And then most people didn't use transformation. Most people tried to make another table, which is completely unnecessary. I know that. Okay. Any questions? All right. Okay, we're going to talk about inverse functions. Now, I'm going to start out by doing the inverse of this one. Okay. Your inverse function is easy to get from the table. So if you want to graph the inverse of this function, it's really easy. Assuming you know how to get the correct table and the correct thing. People see the -1 and it looks like the reciprocal of f of x. And I understand that it can look like that, but this means the inverse function, not the reciprocal. The difference. And that's a little confusing because it's a little ambiguous. There's a good reason for the confusion, but okay, so you've got the table for a function here. You can write down the table for the inverse function. You just reverse the column. So your y's become x's and your x's become y. You got 1/4, 1/2, 1, 2, 4 here. And you get -2, -1, 0, 1, 2 here. Well, that was really tough. Okay, do we understand what I just did? Might not understand why, but do you understand that I just reversed the column? And now I could sketch a graph of this thing if I had room on this board. I don't, so I'll just redraw the graph as a basic exponential function. Without being overly careful. Okay. Kind of looks like this. Not a great graph. Okay, now the inverse function. First this place, the values go from 1/4 to 4. I'm sorry, the x values go from 1/4 to 4, right? Then I have to extend my x-axis a little bit. Fortunately, I anticipated that. My y-axis is okay, except it has to go into negative numbers. So it's reach down as far as -2. There's -2, and see that's -1. So we're going to draw the graph of the inverse function. So 1/4, -2. That means x is 1/4. Now let's see. If this is 1, well, we've got to find 1/4. There's 1/2, there's 1/4. Y is going to be -2. That's going to put us down here. One-half is going to give us -1. X equals 1, y is going to be 0. X equals 2, y is going to be 1. Well, there's 1. And there's 2. And when x equals 4, y equals 2. So y equals 2 is here. X equals 4 is here. We got this point. Okay. And if we want, we can draw the graph. Okay. There's kind of a symmetry to these graphs, right? It's like this graph is a reflection of this through a line that goes out like this. Okay. This is inverse of x, which we call the log base 2 of x, the base 2 logarithm of x. This is what a logarithm is. Now, later on in the course, we'll study the properties of logarithms. And you're going to find they aren't too bad. If you understand where they come from, understand this is an inverse function, then the harder properties become much easier. Okay, so an inverse function make a simple statement, doesn't quite say everything, but gets the whole idea. You switch X and Y. All right. Because if you understand how we did the table, we switched the X and Y values. That's exactly what we did, right? Now, let's see how that works. I'll give you the formula for it. If y equals f of x equals 2x plus 6, so write down what you get if you switch x and y. And just, just switch it because it gets a little confusing if you try to do the function notation. You're going to say this. You're going to switch x and y, and you're going to solve for y. So let's see how you do with that. Now, what could I possibly mean by switch X and Y? Here's Y, there's X. We're going to switch it. I'll put X here. We're going to put Y here. That just mimics what we do with a graph, right? Our X's become Y's, our Y's become the X's. Okay? So if you haven't done that, do that. You replace Y's by X's, you replace your X's by Y's. Then you solve for Y. Okay, you replaced that X by Y, but you didn't have any Y in your function. You had an F inverse there, which is reasonable. But if you look at what I wrote Y equals 2X plus 6, right? So if you write that equation, then you'll have an X. Okay? So you're doing the right thing. It's a function that there's confusion a little bit. Yeah. This. And I don't see where you switched your X and your Y. I don't see that equation. You could do this and it would all be consistent, okay? That wouldn't be a bad thing to do, but just what I wrote down there, you got X equals 2Y plus 6. Make your Y into an X, you make your X into a Y. So you didn't copy down the X equals 2X plus 6, okay? So it's kind of important to copy that down so you can switch the X and Y values. How you can do that easily. You're not good at the solution, but you know. The X has to be divided by well. So you got the whole X minus 6 divided by 2, that means the other thing gets to the other thing. Why are we doing? And you still got it. Yeah. But we can't provide this part of this. Other than that, you're doing the right stuff, but you can't provide this part for one side of the equation and not the other. Okay. You write this right next to this. These are two different equations. So somehow things got confused where you multiply that X by the negative 6. Okay. Put it out in a column so you don't get misled. That's okay. Okay. So you got X equals 2Y plus 6. You solve that for Y. First of all, and I gotta say, well, we'll get to solving linear equations, but you really have to be able to solve linear equations. Okay. You quickly get this, subtract 6 from both sides, there you have it, right? Then you divide both sides by 2. You don't pick and choose what you divide by 2, you divide everything on both sides by 2, right? Means I divide the whole x minus 6 by 2, and by the distributive law, that means I've got x divided by 2 minus 6 divided by 2. Okay? The division by 2 is just multiplying by 1/2. You multiply 1/2 by x minus 6, you get 1/2 x minus 1/2 of 6, right? So the distributive law works for division as well as multiplication. So So well, that means the f inverse of x is a function like f inverse of x equals x over 2 minus 3. Okay. So now tell me, definitions of these functions, f of x, 2x plus 2, f inverse of x is x over 2 minus 3. I'll circle those. What's f of f inverse of x? What's f inverse of f of x? Do that and then simplify those results. I'm going to turn this off. Okay, these are composite functions. Now, this is something that been assigned and done, right? Section 1.4, whatever it was, I think it was 1.4. So just last week, okay? So if you can't write out those steps, you haven't done enough on the composite functions, and you need to review it. Absolutely necessary. You have to know how to do composites. And we've done it extensively in here, so I'll remind you, and I think once I remind you, everybody will be okay, but make sure you have these things down. As I've said, it's very profitable to click through the videos. Just remind yourself what was done as soon as possible after class, so don't lose it. Okay? And then once you work the thing with whatever aids that you're using, videos, online resources or whatever, put those aids away. A day or two later, come back and do it again. Make sure you know how to get the solution. Okay? If you don't do that, your results in this course are not going to be nearly as good. It doesn't take that much extra time. Of course, if it does take extra time, it means you're over reliant on the resources and didn't really learn it. Okay? And you gotta be able to distinguish that. You gotta know when you know something. The way you know when you know it is when you can do it without help. Okay? And there's, I mean, in any assignment, there's some things that are harder than others. If you don't get the hardest thing in the assignment, it doesn't mean you're gonna fail the course. Okay? You're probably not gonna make an A, but maybe if it all comes together when you review for your test. Okay? If you get most of it, and if you can redo most of it without looking at your aids or reviewing the exact way you did the problems, just put everything away and do it. Well, you can do, 3/4 of the problems, 80% of the problems. You're probably going to be okay. Now, ideally, you're able to do them all because that's just more secure. Okay, well, anyhow, please take my advice. Okay, so the two ways I can write this out. But I go to the f of x function. X has been replaced by f inverse of x. So I got to replace x over here by f inverse of x. So that's 2 f inverse of x plus 6. And if you write it this way, you can see clearly how f inverse of x has taken the place of x. You have to see that. You have to know that. Okay? Then you have a formula for f inverse of x. That's 2 times x over 2 minus 3 plus 6. Okay? Now there's some simplification that can go on there. That's one way to do it. The other way to do it is just plug the whole x over 2 minus 3 in for x. So you get the x over 2 minus 3 here, okay? You're going to end up with the same thing. And I've demonstrated it a number of times both ways. You might want to review that. And maybe having been reminded, you say, oh yeah, duh, I know how to do that, okay? And that would be good. But I have to say, at this point, most of you don't know how to do composites. Okay? If you need a reminder, you don't know it. Now that's kind of okay until you need it. Then you end up having to take extra time, you don't understand, you get confused, okay? Best if you know it before you need it. But as I said, if you pull it together before the test, that's feasible. If you know how to review for a test. Okay. But having done it, you should recognize what to do. So let's see how you do that. Some of you are having too much trouble with the algebra. Okay. I just got to say this. You really need to consider going to the mark, getting somebody to work through some of these problems. They're not the problems that you got to submit for homework, but similar problems. Okay. It's algebra 1 type stuff. Might be that you just haven't done it in a while. Too many of you are too insecure on the algebra. Okay. You really need to get some help if you can't simplify that, for example. Okay. So I'll continue. I'll finish simplifying that. And multiply through by 2. It's a distributive law. You have to be able to use a distributive law. Okay. And it's x over 2 not x over 3. Okay. Well, that's the same as 2 over 1 times x over 2 minus 6 plus 6, right? Okay. And 2 over 1 times x over 2 is 2 over 2 times x over 1. Of course, -6 plus 6 is 0, right? I'm just making something up. Note that that's much as 0. Which equals 1 times x over 1, which equals x. That's why 2 times x over 2 equals x. Now you can do that in your head if you just think 2 over 1 times x over 2, right? And see, well, I could write that as 2 over 2 times x over 1 because the numerators still multiply out in the denominator as well. So I'm saying that this is equal to x. Okay, I prefer that you don't try cancellation because people cancel wrong. I really want you to think about the algebra and why these things work so that you don't make mistakes, okay? And I think I've said it before, 90% of people who come into pre-calculus class don't know how to cancel. They just cross things out indiscriminately and make fatal errors, okay? Of course, most of them are still alive, so they're not fatal in that sense. Understand what I mean? Let's see why that cancellation works. And that's not a cancellation, that's just an indication that -6 and 6 is 0, and everybody knows that. Okay, so anyhow, you get x. And if you do f inverse of f of x, you get, going to the formula for x inverse, I'm going to replace x by f of x. Then I'll have f inverse of f of x equals f of x over 2 minus 3. Okay, so I get and that equals then f of x is 2x plus 6. Okay. Well, that's 1/2 of 2x plus 6. Very similar to what I did here. I won't even comment this time. But that's 2x over 2 plus 6 over minus 3 equals over 2 minus x over 1 plus 3 minus 3, which equals, I'm going to kind of shortcut a little bit, x, because 3 minus 3 is 0 again. 2 over 2 is 1, x over 1 is x. Give it 1 times x, which is x. Okay? So there it is. Now, this confirms that you have inverse functions. Okay, and this is your test for inverse function. This thing tells you whether you have inverse functions. Okay. Now you're going to see a lot more than this in open math, but that's an overview how you do inverse functions. So we're going to do another one. The algebra gets hard. Okay. And now you want to use the logic over here. We switch x and y. course, we don't have y here, right? But f of x is your y value, right? So we start with y equals 1 over x plus 5. Like here, we started with y equals 2x plus 6. What do we do next? Here, you might be solving for that 2 plus 3. How do we do that? Okay, we did well with that. Okay, so to do the inverse of this function, we first write this as y equals 1 over x plus 5, because, of course, f of x is your y value, y versus x. Okay, so what do we do with this? Well, I've got an x plus 5 in the denominator. When I have denominators, I multiply both sides of the equation by the common denominator, so I don't have denominators anymore. Otherwise, you get confused. And I don't know how to convince people to do that because it's so important. But you get y times x plus 5 is 1 over x plus 5 times x plus 5. Okay. Now this could be written. Get a little noisy over here. Good to see you. Okay. Got it. So you rearrange this, you get x plus 5 over x plus 5 times 1. Okay? Or 1 over 1 if you want. Well, x plus 5 divided by x plus 5 is just 1, so this whole side becomes 1. And here you distribute, you get xy plus 5y. Right? Now you got to solve that for y. Now, if your algebra is pretty good, you know what to do, but it's probably been a while since you had to do it. You can look at that and get a little confused, but it's pretty simple. You factor out the y. And it's x plus 5, not x plus 1. And you know what I did? I started with this, and I'm solving for it. I get y equals 1 over x plus 5, don't I? That's because I didn't switch the x and the y. And well, we gotta be sure we switch the x and the y. Kind of treating this as though I've already done that. Let's fix it. Can we switch? X and y, we get x equals 1 over y plus 5. Multiply both sides by the common denominator, y plus 5 times x equals y plus 5 times 1 over y plus 5. And you distribute, you get xy plus 5x equals 1. Same steps I did before, but now I've switched the x and the y, so I'm not going to get back my original equation when I solve for it. Incidentally, I could have gone on with what I did and then switch x and y at the end. Solve for x and then switch. But no, I'm not gonna do that. Okay, so now I factor out the x. I write this, just use law tells you this is just x never mind. Okay, so we subtract 5x from both sides. Trying to figure out how I'm going to get all this written. So we get xy plus 5x minus 5x equals 1 minus 5x. So that xy equals 1 minus 5x. I've got a little room here, so I'll use it. If I've got xy equals 1 minus 5x, how do I get y? I divide through by x, right? So I get xy divided by x equals 1 minus 5x divided by x. That's like x, not 1. Okay, and x over x is 1. Y over 1 is just y, so you get 1 times y, and you get y equals 1 minus 5x over x. Then what do? You don't stop there. You go ahead and check to see if f inverse of f of x equals x. So this is your expression for f inverse of x. I'm not going to do that stuff. I have to let myself go through here, but f inverse of x is y, which is 1 minus 5x over x. Now your book is going to, and your videos are going to show you a lot more examples of that sort of thing. But that's the general overview. You switch x and y, whether you're doing a graph or solving an equation. And then graphing. You solve the equation for y if you're doing it algebraically.